All right, so you guys made a pedigree of the blue people, and you should have found out that it was recessive. One, because there was something called a carrier, and two, because it skipped generations. So, what we're going to see here is this pedigree here. It, so some key things is we're going to determine if it's dominant or if it's recessive. So you're going to need to look at the pedigree. The biggest key thing is if there are carriers. Carriers are people that are heterozygous, so they're big, little. What a carrier means is this guy carries a little letter, but does not have the trait or the disease. That means the disease has to be recessive because if it was dominant, he would have it. He wouldn't carry it. He would actually have the disease because he has the big letter. All right, so it has to be recessive because he carries it, but he does not have the disease. All right, so if we look down here at our pedigree, these people have the trait. All right, these people are carriers here. These ones that are halfway filled in. All right, and the reason why they're carriers is because they don't have the trait, so they're not completely colored in, but they carry the gene. All right, and we know they're carriers because they pass on their gene to one of their kids. All right, so they both if this guy is big A little a, this guy is big A little a, they both passed on a little a to that kid. And then one of them passed on a big A. Actually, they both passed on big A's to all these kids. All right, because they're all homozygous dominant. They're not carriers. All right, one mistake on this pedigree, well, and we won't worry about that right now, but so these guys are all, the carriers are halfway filled in. So this trait is recessive. So that's the biggest thing. If it skips generations or if it's recessive, um, and then all you have to do is go back and use Punnett squares for the other questions. So what this question here is asking, it says if the male number 3 in generation 4, so that's this guy right here, males are squares, and the female number 2 in generation 5, so that's this girl right here, were to have a child, what is the percent chance that their child will have a trait? Well, neither of them are carriers, and neither of them have the trait, so they have to be big A, big A. So you do your Punnett square, and they're all going to have be homozygous dominant, or big A, big A, which means there is a 0% chance that they would have a child with the trait. All right, and I could go on and do more of this, but this is just for help. So that's what you're doing. You're looking at these, determine if it's dominant recessive. If it's recessive, that means the people who are colored in have the trait. If it's dominant, like you see this pedigree here has no carriers, and it's in every single generation. That means the trait now is dominant, so that means this guy would be big A, big A. All right, and then these guys would all be little a because they don't have the trait. All right, and the trait is dominant, so that means the other ones have to be recessive. All right, but most of the diseases we talk about here are recessive. So generally, the people colored in are going to be recessive. There's just going to be a few times where they're going to be dominant. All right, and then all you have to do is figure out, like, what are the genotypes of these two people going to be? Well, you have to look up. If this one's little a, and this one's big A, what's the only way genotypes that these guys can be? That's pretty obvious there because this guy can only pass down a big A and this one can only pass down a little a, so they have to be big A, little a. All right, if you need help, this is just kind of helpful so you guys can go through and look at these.